Hello everyone, welcome to our new video on tree traversal. Here we will learn some different traversing technique of a binary tree. Traversing means visiting each and every node in a tree. And there are three most important traversing technique that has been used are called preorder, in-order and post-order. The difference between in these patterns is the order in which the node is visited. Now, in case of a pre-order traversal, first we visit the root node, then recursively we visit the left subtree in pre-order traversal, and followed by a recursively pre-order traversal of the right subtree. In case of in order, we first visit the left subtree of the binary tree in an Inorder traversal, then we visit the root node, and finally we do a recursive in-order traversal of the right subtree. In case of post order, we first recursively traverse the left subtree, then followed by right subtree, and finally we visit the root node. So this is the logic behind of these three traversals: pre-order, in-order and post-order. For simplicity, we will just remember the terms. In case of pre-order, we start from the root, then followed by left, visiting the left subtree, then we will visit the right subtree. In case of in-order, we will first visit the left subtree, then followed by root, then right subtree. And in case of post-order, we will first visit the left subtree, then right subtree, then finally we will visit the root of the binary tree. So let's see how we can work with these three orders with the help of an example.
By the algorithm of pre-order traversal of a binary tree, the first step is that we have to visit the root. Next, we will traverse the left subtree in pre-order. In the third step, we will traverse the right subtree in pre-order. So, with this algorithm, let's find the pre-order of this binary tree. So, in pre-order, we will start from the root. According to the rule, visit the root. So we will start from the root. Here the root is a, so first we will visit the root, means a will get printed, and after that we will visit the left subtree. Now if we move to the left subtree, we are getting another node which is b, and we will print the node b as we are visiting the root. In case of the left subtree, b itself is the root for the left subtree. So obviously we will visit the root and print it. If we move towards left, we found d. So again, visiting the node d, we will print the node d. After that, we are going to find the left and right child of d. Now as there are no left child of the d, so we start traversing towards right. Now first we have to print the root, next we have to visit the left one, and afterwards we have to visit the right one. Since there are no left subtree present of this d, so we will move towards the right subtree of d and print g here. Now we have finished traversing our left subtree of the whole binary tree B, D, G. Now we will move on to the right subtree. So now we will traverse the whole right subtree, and again first we are getting the node C. So we will print the node C. Now C has two children, E and F, and after visiting this C, according to the rule of preorder, we have to traverse the left subtree. So if we are traversing from C, then we will first move to the left subtree E and print the node that we have traversed. Now we have finished traversing the left subtree E. Then we will move forward and traverse the right subtree. So we have visited the root in case of only this tree. We are considering only this part. So we have visited the root here. We have traversed the left subtree, and we will further move towards right subtree. Now in the right subtree, if we move towards the right subtree, so we have to traverse only this part. In this part, again it is the parent node, so we will visit the parent node and print the value. The only thing that we left is traversing the left subtree. So again we will move forward and traverse the left subtree. We have another node which is H. We will visit the node and print the node. Now at this point we can see that we have visited all the nodes of the binary tree in preorder, and that is the preorder sequence A, B, D, G, C, E, F, H. A, B, D, G, C, E, F, H. That is the preorder sequence of this binary tree, and we will stop the process here since we have visited all the nodes. Now there also exists a shortcut method. Since we have to traverse this binary tree in preorder traversal, so obviously we will start from this point, node A. So we are starting from node A. Now we move towards anti-clockwise. So from A we move towards B. So since we started from A, we visit each and every node and we will print the value. So we are starting from node A. So obviously this is our first node, so we will print the value A. After, if we move anti-clockwise, then we have found node B, so we will print the value, this one we have visited. After B we move and reach on to D, so we will print the node D. Now after D we have visited G, so after D we will print G. Now after G, since we have completed this whole part, so we move towards the right subtree, and again we have reached at point C. So after G we will print C, then E. So after C we have visited the node E. After E we have visit F. C is already visited, so after E we have visited F, and after F we have visited H. So from here all the nodes are visited, so we will stop the process from where we have started. So in this way we can also find the preorder sequence of the given binary tree, and that will be the same A, B, D, G, C, E, F, H. That is the also A, B, D, G, C, E, F, H. the same pre-order sequence that we have found with the help of the algorithm. Visit the route, then traversing the left subtree in pre-order, then traversing the right subtree in pre-order. So with the algorithm we can also find the pre-order sequence, and this is the same procedure, just this is the shortcut procedure that we have traversed. We are starting from point A and moving towards the left side and visiting each and every node at least once, at most once. We will visit each and every node at most once and printing the visited node. So in this way we can find the pre-order of a binary tree. By the algorithm of post-order traversal of a binary tree, first we have to visit, or we have to traverse the left subtree in post order. Second, we have to traverse the right subtree in post order, and finally we have to visit and print the root. So let's find out the post order traversal of this binary tree. So we will start from visiting and traversing the left subtree in post order. So A is the root, so we will start from A and we will move towards the left subtree. Again in the left subtree we have visited a node B which has also the children, so we will move further left and visit the node D. After D we are looking for the children in left subtree. Since there are no left subtree of D is present, so we will traverse the right subtree in post order. So in the right subtree we have only one node, that is G. So we will visit and print the node G. Now in this subtree the right node is visited. There exists no left node, the right node is visited. Now finally we will visit the root of this subtree. So after G, D will get visited and will get printed. We have finished visiting this part. Now we will move further for the left subtree, this B, where for this left subtree where B is the root, we have visited the left part, we have also visited the right part, so we will visit the root of this one. So here after D, B will get printed. Now for the whole binary tree we have already visited the left subtree. We have completely visited, traversed the left subtree. Now we will move on to traversing the right subtree in post order. Now while traversing the right subtree, first node is C. So again C has two children, E and F. So we are considering only this part for the right subtree, and here C is the root. If we consider only this part, so C is the root which has left and right children. So obviously we will move towards left and we will traverse towards left, cause in post order first we have to traverse the left subtree, then right subtree, then root. So we will move towards left. Now here E is the only single node having no left and right subtree. So therefore no left subtree is present as well as no right subtree is present. So only E is there. So we will visit the node E and print it. Now the left subtree, we have visited the left subtree of C. Considering this part only, we have visited the left part, so we will traverse towards the right part. So here in the right part we have a node F, and all, as well as F has one children in his left, which is H. So again we will move further left and visit and print the node H. So left, we have visited the left part. Next we will move on to the right part. Since there exists no other children of F in right part, so therefore we will visit the root. We are considering only this subtree. We have visited the left part as there exists no right part. So our next step is to visit the root, and here we will visit the parent F and print. Now considering the right subtree of the whole binary tree, we have visited the left part, which is E. We have also visited the right subtree F and H and printed. Now the left part has been visited, the right subtree is visited, so finally we have to visit the root, so which is C. So we will visit the root and print it. Now considering the whole binary tree, we have visited the left subtree and we have traversed the left subtree and visited all the node. We have traversed right subtree, again we have visited all the nodes. So the one thing that is left here is visiting the root of the tree. We have completed the left subtree traversed, we have successfully traversed the right subtree, so the thing which is left is the root. So now at last we will visit the root and print it. So here we will stop the process as all nodes are successfully traversed. There also exists a shortcut method. Here we have to start from the node, visiting the node A, then we will further move towards clockwise and try to visit the node C. So A is our starting node, so first we will visit A, then followed by C, then F, then H. After H we will visit E. After E we will visit B, then D, then G, and we will go back to A and stop the process. Now the way we have visited these nodes, we will start writing from our right hand sides and move towards left. So we have started from A, so the first node that we have visited is A. After that we have visited C. After it we have moved and visited F, then H, then we have visited E, then after E we have visited B, after B we have visited D, and after D we have visited G. So here this is the post-order traversal that we have visited, G, D, B, E, H, F, C, A. This one, G, D, B, E, H, F, C, A. So here we have to, what we have to do, we are starting from A and we are moving towards this direction, and we have to start writing from the right hand side and we will move towards left and write the other nodes. So in this way, this is the shortcut way we can find the post order of the given binary tree. By the algorithm of Inorder Traversal, first we will traverse the left subtree in Inorder. then we will visit the root, and finally we will traverse the right subtree in order. So let's traverse the binary tree in an in-order traversal. So first we will traverse the left subtree. So starting from the root A, we will traverse the left subtree, so we will move further towards left and reached at B. Since B has a child, so we will move further left subtree. We will traverse the left subtree of this B, and we have reached in D. Now in case of D, we are considering only this subtree. In case of D, there are no left subtree present. So since there are no left subtree are present, we will visit the root and print it. So D will get printed. Now since there are no left subtrees present, and second step, so we will move further to the second step. So we have visited the root and print it. Now our last job, which is we have to visit the right subtree in Inorder Traversal. So it looks like left, root, right. Left is not present, so we have visited the root. Next we will move further to the right. In right we have G, so we will visit and print it. Now we have completed visiting the left part of this left subtree B. If we consider this part B, D and G, so we have traversed the left part of B, as there exists no right part. So after left we will visit the root, which is B. So after D, after G, we will visit the root B. Now there exists no right part, so we have visited the left part. Next we visited the root, and there exists no right part. Now for the whole binary tree, we have visited the left subtree B, D and G. We have visited the left part. Our next job is to visit the root. So after B we will visit the root A. Now we will move further towards the right subtree, and we will visit this right subtree in order. So again, considering this right subtree C, E, F and H, we have C, and C has two children, E and F. E and F, C has two children. Now considering this right subtree, starting from C, first we will move towards left and visit the node and print it. So after A, E will get printed. Now we have traversed the left part. We will move towards the root and we will print it. So after E, C will get printed. Now we will move towards right, and in right we have found the node F, which also has one children H in his left. So again, considering only this subtree where F is the parent node and H is the node in his left part. So again, the law of the in order, we have to first visit the left part, then root, then right. So considering only this part, we have to first visit the left part, which is H. So H will get visited and printed. After H, we will print its parent node or root. F, we have visited the left part, we have traversed the root and visited it, and since there exists no right part, so we will stop the process here. Now after this, we can see that we have traversed and visited all the nodes of the tree. So this is the in-order traversal of the given binary tree. left, first we have to visit the left subtree, then root, then the right subtree. Now we have visited all three types of traversal. We have done all three types of traversal: pre-order, in-order and post-order of a binary tree, and we have found one thing, that in case of pre-order, this is the whole binary tree. In case of pre-order, the first node is the root of the tree. In case of post order, the last node is the root of the tree. And in case of in order, the root exists in between the left subtree and right subtree nodes. So here we can see that A is the root of the tree, which exists as a first node. That is the first node in case of pre-order, and that is the last node in case of post-order traversal. And in case of in-order traversal, this root node lies between the left subtree and right subtree. So DGB, this is the left subtree of the binary tree, and ECHA, that are the nodes in the right subtree of this binary tree, and the root that exists in between the left subtree nodes and the right subtree nodes. So this is the all three types of traversal, tree traversals: in order, pre-order and post order.
So this is how we can traverse the node of a binary tree, as there are exist three different traversing orders: pre-order, in-order and post-order. And we have seen in the examples that how can we traverse each and every node with three different orders. Just remember here one thing, that while in case of in-order traversal of a binary search tree, the traversal always gives the nodes in sorted sequence or in ascending order. So thanks for watching the video. If you like the video, then hit the like button and subscribe to the channel and hit the notification bell icon for regular updates, and share the video with others. Thanks for watching.